At this point, we've had a look at this signal on the oscilloscope, brought out on GPIO 133. And this VHDL simply takes this 10 kHz clock in, divides it by 10, and writes it out. Now we saw that on the oscilloscope, and luckily that was a signal that was slow enough to view on such an instrument. But in general, we often want to look at lots of internal signals, often running at quite high speeds. And the best tool for that is the on-chip logic analyzer called SignalTap. SignalTap is additional hardware that gets added to your design straight onto the FPGA. So it's going to use up quite a lot of hardware when we add it, as you'll see. So if we look at what we've got now, we've used 5 logic elements. As you'll see in a minute when we add SignalTap, that's going to change significantly. So what is it we want to do? Well, we want to sample this signal at a rate that's high enough to see all the changes. So this is a 1 kHz signal, that's what we believe it to be. In fact, we know that from the scope. So the 10K clock would be reasonable, so that we measure this signal 10,000 times a second, 10 times its own speed. And that's what I'm going to do now. So it's easier to show you than to try and explain it. So we go to Tools, SignalTap 2 Logic Analyzer, and this is going to create us a SignalTap file, which we'll add to our project. Okay, so this is what we see to begin with. Now note the 2 tabs here, Data and Setup. We start in the Setup page. So if not already done, we choose up here our debugger. If this doesn't appear, that suggests your board's not plugged in. Then we need to check the SOF file. Now that's the file we use to program anyway, so we know that one. And while we're using SignalTap, we use this button here to reprogram the device. Now I mentioned that we need a clock to set the sampling rate, and that's the all-important clock signal here. So we click this button to choose, drop down here, and I'm going to scroll to the top and choose Design Entry and List. So there it is, clock 10K. I'm using a 10K clock to drive the logic analyzer. That therefore means we cannot measure this thing. We're using this thing as the clock for the logic analyzer itself. Now note also this, data, sample depth, 128 bits of RAM. So as we sample our signals, they are going to be stored in RAM. And when the RAM is full, it will stop and send the data back to Quartus for us to look at. This is how it manages to work in real time. So it buffers the measurements in RAM. Now, we're going to have 10 samples for every cycle of our signal, so 128 bytes is more than we need, so let's just have 64 bits of RAM. Okay, let's now define the signals we want to measure. Well, there's only one, so double click, same trick, I'm going to go to the top one, List, and it's one of the GPIO 1 pins, there it is, GPIO 133. Add that one, insert, and you'll see this red bar appear. If you have the subscription version, you can do a rapid recompile. For the web version, you need to do a full compile. So that's this button here, Start Compilation. So I'm going to do that now. Now it'll ask a set of questions the first time you do this. The answer is always yes. So stp1.stp has been modified. Yes, save the changes. Put it in the default place with the default name, and yes, I do want it added to my project. Now we wait for it to compile. Remember, this is adding additional gates to our FPGA design for test purposes only. So in some senses, again, the sheer act of measurement will have some impact on the routing and layout of our design, but we hope it's minimal. Okay, that's finished building, and we can have a look and see the compilation report. Now we're using 497 logic elements as opposed to 5. Okay, let's get the SignalTap file back. here it is. Now we have a yellow bar, invalid JTAG configuration. What that's really trying to tell me is I need to reprogram. So I click reprogram. Now it's saying ready to acquire. So remember, we're going to fill 64 bits of RAM with samples of this signal. To do that, we click this button, Run Analysis. It starts, it's acquired, and there it is. So Control space to zoom in, Control Shift space to zoom out. The numbers along the top are clock cycles. So remember, we had a 10K clock and we're looking at a 1K signal if this has worked. So there should be 10 clock ticks in every cycle. 1, 2, 3, 4, 6, 7, 8, 9, 10. Indeed, this is correct. This is a 1 kilohertz and symmetric signal, so it's worked. Okay, incidentally, if you don't want to switch windows all the time, go to Window, click Attach Window, and now it's a tab in here. Let's just save it. So you can reopen your SignalTap file anytime by just double clicking it. You could go in and make changes. Don't forget though, in the setup mode, there's this tab here, always be careful and think about how much RAM you need. You think about how fast you're sampling and the speed of the signal you're looking at, how many bits we need to acquire.